Welcome to this explainer. I am your master auditor, and today we are stepping into the digital kitchen workshop for a razor-sharp, high-stakes grade makeover. We are taking an uncompromising look at Cambridge AS and A-Level Math 9709, specifically targeting a massive vulnerability that ruins otherwise perfect exam papers: integration by parts. Listen to me. I have audited countless exam scripts, and I see the exact same kitchen disasters over and over again. In my workshops, I constantly see two distinct types of students. Let's call them Apprentice Alex and Apprentice Sam. Apprentice Alex is the overcomplicator. Alex dumps massive piles of raw, unanalyzed, factual equations and definitions onto the page without ever cooking them down into a clear, logical, mathematical argument. Then you have Apprentice Sam. Sam is the fast cook. Sam rushes the preparation steps, creating these beautifully written final lines, but completely forgets to include the core ingredients, the actual step-by-step working demanded by the question. Both of these approaches are completely broken, and examiners can spot them from a mile away. Today, we are going to structurally audit your mathematical process, strip away those bad habits, and rebuild your strategy to secure those elite, top-tier results.
You might be wondering, why are we focusing so intensely, so obsessively on this one specific mathematical technique? Let me give you the exact reason. 15. Integration by parts accounts for approximately 15% of your total examination marks in these papers. Just think about that for a second. This single number, this one recipe, literally represents the difference between a standard, forgettable pass and an elite, world-class grade. If you mess up your integration by parts, you are leaving an absolute goldmine of marks on the table. It is a heavy-hitting, absolutely critical process that you must master. You cannot fake your way through it, and you cannot just rely on memorizing the final shape of the answer. We need to treat this like a Michelin star dish, where every single step is evaluated.
Here is our masterclass menu to structure your approach today. 1. The raw ingredients. 2. The cooking process. 3. Plating and presentation. And 4. The examiner taste test. Let's get right to it.
Section 1. The raw ingredients. Let's inspect the foundational theory in why blindly mixing formulas is a recipe for disaster. We have to start with the raw essay text of your math. The core formula for integration by parts is beautifully simple on the surface. The integral of u dv equals uv minus the integral of v du. But here is where Apprentice Alex gets it completely wrong. Alex just writes this formula down, hoping the examiner will hand over marks for basic memory recall. But top-performing students don't just memorize definitions. They exhibit a connected conceptual understanding that transfers effortlessly to entirely new and unfamiliar exam scenarios. Mastery means knowing exactly why you are applying this formula. It requires a deep understanding of causal relationships. You have to strategically determine which part of your given complex function should act as u and which part should act as dv. If you get this raw ingredient selection wrong at the very beginning of the question, the rest of your math will literally burn up in the pan. Your resulting integral will become infinitely more complex, and you'll find yourself trapped in a mathematical dead end.
Let's look at the principal examiner reports. They explicitly highlight that referencing cross-topic connections acts as the perfect seasoning to immediately elevate your overall grade. For integration by parts, this cross-topic connection is your strategic command word, the IATE rule. That stands for logarithmic, inverse trigonometric, algebraic, trigonometric, and exponential. This hierarchy is your definitive, unbreakable guide for choosing your U. Let's say you are integrating the product of an algebraic function, like x, and a trigonometric function, like sin x. Apprentice Sam might just pick U randomly to save time, but the IATE rule explicitly dictates that algebraic comes before trigonometric. So you must pick the algebraic part, the x, as U. This instantly simplifies the derivative, effectively cooking down the complexity of the equation. Making these precise, intentional connections is exactly what examiners are truly looking for. When you miss this, you lose 60% of the available mark yield instantly because your core seasoning is completely missing.
Section 2. The cooking process. Let's step up to the stove and execute the technical methodology with what we call the method mark strategy. You must strictly follow this unbreakable 5-step sequence. I literally watched Alex and Sam debate this exact sequence under a simulated timeline recently. Alex wanted to overload the layout, writing out massive paragraphs of theoretical terminology, while Sam was fighting to just skip to the end and build a fast analytical logic string before the kitchen timer hit empty. But I stepped in with a red pen because both were failing. Here is the actual framework you need. First, deconstruct the question by using the LIAT rule to correctly assign u and dv. Second, extract your data by accurately differentiating u to find du and integrating dv to find v. Third, select your framework by precisely plugging these 4 elements into the primary formula. Fourth, execute the notation by integrating that remaining trailing term. And finally, step 5, present the verified final algebraic result. If you skip any of these, like Sam, or if you drown them in unstructured noise, like Alex, your response frame shatters.
Look at this stark contrast between a sour, low-scoring answer and a high-tier response. A raw answer is just writing down the final mathematical result without any visible analysis. That is going to earn you exactly 0 marks. Examiners do not just want to taste a raw, isolated final number. They want a fully cooked answer. They want to see you executing your analysis with a clear procedural framework and entirely visible working. This is the method mark strategy in action. The Cambridge marking scheme awards M1 method marks specifically for showing the exact logical steps of the formula application. If you skip straight to the A1 accuracy mark at the final line, the examiner's red digital pen is going to slash right through your paper. They need to see exactly how you cooked the math.
Section 3, Plating and Presentation, because presentation conventions in this syllabus are rigorously and ruthlessly enforced. Kitchen freeze. Right before we unlock this 5-star formatting structure to completely transform your final grades, we need to optimize your revision recipe. Take a second right now to subscribe to Ace the Exams and hit that notification bell so you never miss our weekly grade makeovers, whether you are cooking up results at IGCSE, O-levels, or ASMA levels. All right, back to the pass line. To secure the absolute highest marking bands, your presentation must follow strict mathematical conventions. Think of this as your Peel structure for mathematics: point, evidence, evaluation, and logic. Clear annotation must be visible at all times. If you are solving an indefinite integral, did you remember to plate it with the constant of integration, the plus c? If you forget that, the dish is ruined. If it is a definite integral, have you properly substituted your upper and lower bounds using the appropriate bracket formatting? You have to perfectly balance executing the complex analysis with flawlessly presenting the final results. Correct terminology and appropriate formats aren't just suggestions, they are mandatory requirements. When analyzing a complex integral, you have to systematically extract limitations and assumptions to show the examiner exactly how they affect your final conclusions. Consider alternative interpretations that shift your outcomes. As we discussed, if you choose the wrong u, your resulting integral restricts your scope and becomes unmanageable, so you must evaluate your evidence quality using ILE 8. But you also have to be hyper-aware of limitations in the formula itself. Sometimes, applying the formula once just isn't enough. Take a classic high-tariff question like integrating x squared times e to the x. You literally have to apply the integration by parts framework twice to fully break down that x squared term. Furthermore, you must account for assumptions that alter your variables. What happens when you hit a looping integral like e to the x sine x? It just keeps cycling back on itself. In that scenario, your evaluation strategy must shift. You have to compare algebraic approaches, treating the entire integral as a variable, say I, and use algebra to isolate it and solve. This is how you perfectly blend your factual knowledge with top-tier evaluative logic. Section 4, the examiner taste test. We have reached the pass line, so let's conduct a visual compliance audit based directly on the principal examiner reports. Welcome to the interactive viewer taste test arena. I want you to run a visual ingredient scan in your head right now. Here are the top 3 fatal mistakes that cause student responses to taste incredibly sour to examiners. Challenge 1, spot the poisoned sentence logic. The first major mistake is confusing cause and effect. In the calculus kitchen, this translates to mixing up your differentiation and integration steps. I see students constantly integrating their u term and differentiating their dv term. It's a total catastrophic failure of the framework. Mistake number 2 is forgetting to check format and presentation. This almost always manifests as dropping a negative sign right in the middle of the formula, completely reversing the mathematical logic string. And mistake number 3 is providing generic, non-specific answers. Let's dig deeper into that one. Let me use my examiner's pointer to highlight this exact discrepancy. The quote here is absolutely vital. If you rely on unanalyzed factual definitions and fail to link every single point back to the specific mathematical context, you instantly lose massive mark yields. The classic mistake is just scribbling out the U-V formula on the page, hoping it counts as working out. It doesn't. The explicit presentation examiner's demand involves structured, undeniable proof. You need to physically write on your exam paper, let u equal this exact function, therefore du equals its specific derivative. Let dv equal this other function, therefore v equals its specific integral. You must link every single variable back to the unique scenario provided in that specific past paper question. That is the exact level of rigor and precision required to pass the visual compliance audit. I want you to imagine the Michelin dashboard tracking your assessment objectives live. To watch your meter max out to a perfect 100%, your argument has to systematically elevate through 3 distinct levels.
The descriptive level, sitting at around 30%, is simply recognizing that the question requires integration by parts. It's raw. The analytical level, pushing up to 60%, is where you start executing the correct operations, capturing those crucial M1 method marks by setting up the formula. But to hit the evaluative level, that perfect 100%, you have to provide fully justified, flawlessly executed recommendations. By ensuring your procedural method is explicitly clear and heavily documented, you protect yourself. Even if a tiny arithmetic error occurs at the very final plating stage, your heavily analytical working guarantees you still capture the vast majority of the method marks. Let's completely distill this entire masterclass down into 3 universal rules to take into your next exam. Rule number 1, the 3-step ingredient prep. This is your decoding phase. You must aggressively apply the LIATE rule to accurately and intentionally define your U and DV components before you calculate anything. Rule number 2, the heat control formula. This is all about timing and execution. Process the sequence systematically, maintaining a completely visible logic string so you never drop a negative sign or mix up your calculus. Rule number 3, the pass line review checklist. This is your mandatory format check. You never, ever submit your paper without checking for your bounds on definite integrals or your plus C on indefinite ones. Let me leave you with a final provocative thought. Integration by parts is essentially the mathematical reverse engineering of the product rule for differentiation. It really makes you wonder, doesn't it? If we can reverse the product rule to unlock these complex integrals, what other complex derivative rules are hiding in plain sight, just waiting to be reversed to solve the impossible? The math syllabus is beautifully interconnected. Keep your methodology sharp. Practice your past papers using this exact new recipe, and always think deeply about the mechanics driving the math. Subscribe to Ace the Exams, smash that notification bell for more weekly grade masterclasses, and drop a comment below letting me know exactly what Cambridge subject and level you are cooking up next. I'll see you in the next explainer.